Hello? Now? Now audible? Please ask your friends to join the class. My network is not working, so please ask your friends to join the class. So most of the topics is finished. So today we'll statically revise the first part of stability of the beams and truss and stability of beam and truss. Okay. Then we'll revise this method of joints, analysis of truss. So we'll revise the main analysis part in coming days. So those who have missed earlier classes, they can clear their doubts, and means others also can clear their doubts. I got many queries regarding revision class. That's why I'm taking this class. 13 students. What about others? Okay, I'm sharing my screen. Let me know if it is visible or not. Okay.
Structural analysis. Statically determinate beams.
Is it visible?
In this lecture, we are going to answer two questions. What is a statically determinate beam and how to analyze it? A beam is a
Both audio and
properly
video is
supported
okay.
structural member capable of carrying loads that are perpendicular to its longitudinal axis. Such a member is called a beam because the loads cause it to bend, like this. The analysis of such a beam involves
I'll start it from
calculating
the
its
starting,
support
okay? Just let
reactions.
me know if it is okay or not.
In this example, beam analysis entails calculating the three support reactions, AX, AY, and BY. Then, what is a statically determinate beam? A beam is called statically determinate if its unknown reactions can be calculated solely using the equilibrium equations. Now, how do we analyze structural analysis? Statically determinate beams. In this lecture, we are going to answer two questions. What is a statically determinate beam and how to analyze it? A beam is a properly supported structural member capable of carrying loads that are perpendicular to its longitudinal axis.
Okay.
Such a member is called a beam because the loads cause it to bend, like this. The analysis of such a beam involves calculating its support reactions. In this example, beam analysis entails calculating the three support reactions, AX, AY, and BY. Then,
A pin support will have two reactions, AX and AY, in the vertical direction AY and in the horizontal direction AX. And in the roller support side, it will have only one reaction, which is in vertical direction BY. And it is a simply supported beam with a point load at the center. Okay.
what is a statically determinate beam? A beam is called statically determinate if its unknown reactions can be calculated solely using the equilibrium equations.
So we will use three equations of equilibrium to solve the reactions. Okay.
Now, how do we analyze such a beam? Before we can answer the question, let's review reaction forces associated with each type of support. The three most common support types are pin, roller, and fixed supports. There are two reaction forces associated with a pin support, a force in the X direction and one in the Y direction. A roller support provides one reaction force only. Here, the force is perpendicular to the support surface. A fixed support has three reactions, a force in the X direction, a force in the Y direction, and a bending moment about the Z axis.
So your fixed support will have three reactions. That will it will resist your horizontal movement, horizontal force, vertical force, and it will resist the movement. Okay, and your roller support will only resist the vertical movement. It will experience your horizontal motion, and your pin support, it will resist both horizontal and vertical motions. Okay, you should know about these reactions to solve the problems in shear force and bending moment diagram or in trusses. So you should know which support will give how many reactions. Okay.
To clarify, let's look at two examples. Suppose our beam has a pin support and a roller support. Here, there are three reaction forces, two forces associated with the pin support, and one force associated with the roller support. In this example, the beam is fixed at one end, but free at the other end. Therefore, there are three reactions involved here, a force in the X direction, a force in the Y direction, and a bending moment. In order to analyze a beam, it is customary to draw a diagram called the free body diagram, showing the applied and reaction forces and their locations in a Cartesian coordinate system. Note how each unknown force in the diagram has been uniquely labeled. The free body diagram helps with the correct formulation of the equilibrium equations. To determine the support reactions, that is, to analyze the beam, we use three equations. 1. Sum of the forces in the X direction must be 0. 2. Sum of the forces in the Y direction must be 0. 3. Sum of the moments about the Z axis at, say, point A must be 0. The first equation in the expanded form gives us AX equals 0. The second equation gives us AY plus BY minus P equals 0. Third equation gives us P times L divided by 2 minus BY times L equals 0. Solving the third equation for BY gives us BY equals P divided by 2. Solving the second equation for AY gives AY equals P divided by 2. Before we end this session, let's look at 2 more examples. Here, we have a cantilever beam subjected to a uniformly distributed load.
Cantilever beam with your UDL of 2 Newton per meter, and the span length of the beam is 10 meter. So we'll see how to find the reactions and moments in this type of beam.
Let's analyze the beam. First, we draw the free body diagram for the beam. For the purpose of finding the support reactions, we can replace the uniformly distributed load with its equivalent concentrated load. Now we can write the equilibrium equations. AX equals 0. AY minus 20 equals 0. MA minus 20 times 5 equals 0. Solving the last equation for MA gives MA equals 100. From the second equation, we get
So if we equate equations of equilibrium, if you see, the summation of all the horizontal forces is equals to 0. So here in this figure, if we draw the free body diagram of the beam, horizontal force is your AX, right? This AX. So AX equals to 0. Vertical forces will be AY minus y, minus 20y, because this is in downward direction. So I am considering upward direction as positive and downward direction as negative, right? So the load is 10, the load is 2 and the span length is 10 meters. So load will be 2 into 10, which is 20. Okay, in point load we took, if it was point load, we would have taken this 2, right, directly 2, but it is UDL, that means uniformly distributed load. This 2 Newton per meter, this 2 Newton is uniformly spread over the span of 10 meter length. That's why for UDL we used to multiply the span length with the load. So this is 20 Newton. So one is vertical forces in upward direction is AY, in the downward direction it will be 10 into 2, 20. Okay, don't get confused how I got this 20. Okay, equals to 0. And movement about this point, movement of all the forces about a point A. So I know this fixed reaction will generate a moment. This is my MA, so MA. I'm taking the this anti-clockwise as positive they are taking, so consider clockwise as negative. So we know your moment is force into distance, right? So my moment, I know my force is your 20. My force is 20, and what we used to take in UDL, we used to take the half of the span length. That will be 10 by 2, so that is 20. See, force will be 2 into 10. This will be my force, right? And distance I used to take, we need to take half of the span length, so it will be L by 2, so it will be 5. That's how 20 into 5. Okay, when I solve this, I'll get MA is equals to 100 Newton meter. Now let's see what else. AX equals to 0, MA is equals to 100 Newton meter. Now I left with AY, which will be 20 Newton. Simply AY minus 20 equals to 0, so directly I'll get AY equals to 20.
AY equals 20.
So these are my
And the
values
first
of
equation
MA
gives
and
us
AY.
AX equals 0. The second example is a beam with a pin support at the left end, a roller support at the right end, and another roller support at the middle of
So
the
let's
beam.
see, this is
The
called
beam is subjected
as continuous beam. Okay, supported at three supports: pin supports and roller supports at B and roller support at C, and it has 2-point load which is between A and B and B and C. So let's see this continuous beam. This is a continuous type of beams.
two concentrated loads. To analyze the beam, we start by drawing its
First,
free body
first you
diagram.
draw the free body
Note
diagram of
that
the
the
beam
diagram
with
shows
all
four
support
unknown
reactions
forces,
and
two support
external load.
reactions for the pin support, and one reaction for each of the roller supports. Here, the equilibrium equations are AX equals 0,
Then use
AY plus
three equilibrium equations to find the reaction supports. Okay.
EY plus CY minus 2 times P equals 0. 5 times P plus 15 times P minus 20 times CY minus 10 times BY equals 0. Notice that we have 4 unknowns but only 3 equations. Therefore, we cannot solve for the unknowns. The beam is not statically determinate. We will discuss techniques for analyzing statically indeterminate beams later in the course. By drawing equals 0 equals 0. 10 times the equation. We will discuss technique.
So if you see, we have only 3 equations, right? And the unknowns are 4. So we cannot solve this beam. So it is called as statically indeterminate beam. So when these 3 equations will be sufficient to find the support reactions, it is called as statically determinate beam. But we cannot solve when the number of unknowns will be more than the number of equations. So it will become it is called as statically indeterminate beams. Understood the basic difference between statically determinate and indeterminate beams. Hope this part is clear. Any confusion? Am I audible? Hello? Any confusion from this part? How to define statically determinate and indeterminate beam? You can type in the chat box. Hope. Okay, let's move to the next topic. There is network issues. I'm not able to share my screen. Just give me a minute.
In this session, I'm going to talk about
Okay.
stability
Is
of
it visible?
structures.
Screen is visible?
A structural system, be it a beam, a truss, or a frame, can be viewed as a rigid body that is properly restrained by one or more supports.
Okay.
Such a
Let's
system.
start. So let's see.
In this session, I'm going
The
to
topic
talk
is
about
structural
stability of
stability. We'll see
structures.
the stability of this structure.
A structural system, be it a beam, a truss, or a frame, can be viewed as a rigid body.
So this is one kind of beam, this is one kind of truss, and this is called as frames. Okay, this is beam, truss, and these are frames.
That is properly restrained by one or more supports. Such a system is said to be externally stable if it does not undergo any rigid body motion, regardless
Ma'am,
of
I
the
don't see
position
any
of
beam
the
here.
applied.
Please type in the chat box. It will create echo. What happened? Okay, let me share once again. Now it is visible.
Loads. Consider a simple frame structure supported by two rollers. If we apply a horizontal load to the frame, it starts rolling horizontally on the support surface. The structure undergoes rigid body motion. Therefore, the frame is said to be externally
Okay.
unstable. If,
Audio and
however,
video
we
is okay.
replaced one of the rollers with a pin support, the structure becomes externally stable, as the pin prevents the rolling of the frame on the support surface. Let's consider another example.
Nadushmita, video is
Here,
okay.
we have a truss structure that rests on two supports, a pin and a roller. Clearly,
Okay,
the
let's start
supports
from the
prevent any rigid. In this session, I'm going to talk about stability of structures. A structural system, be it a beam, a truss, or a frame, can be viewed as a rigid body that is properly restrained by one or more supports. Such a system is said to be externally stable if it does not undergo any rigid body motion, regardless of the position of the applied loads. Consider a simple frame structure supported by two rollers. If we apply a horizontal load to the frame, it starts rolling horizontally on the support surface. The structure undergoes rigid body motion. Therefore, the frame is said to be externally unstable. If, however, we replaced one of the rollers with a pin support, the structure becomes externally stable, as the pin prevents the rolling of the frame on the support surface. Let's consider another example. Here, we have a truss structure that rests on two supports, a pin and a roller. Clearly, the supports prevent any rigid body movement of the entire structure. Yet, the truss is considered to be unstable. Why? Because here, we have localized rigid body motion. Some of the truss members are not properly restrained. They can have limited free movement. This is called internal instability. A structure is said to be stable if and only if it is neither externally nor internally unstable. To determine if a structure is stable, we need to ask three questions. 1. Does there exist a loading pattern that makes equation sum of the forces in the x direction equals 0 unsatisfiable? 2. Does there exist a loading pattern that makes equation sum of the forces in the y direction equals 0 unsatisfiable? 3. Does there exist a loading pattern that makes equation sum of the moments about the z-axis equals 0 unsatisfiable?
If the answer to any of these questions is yes, then the structure is considered unstable. Consider a simple beam resting on two rollers. Here, equation sum of the forces in the x direction equals 0 cannot be satisfied if a non-zero force is placed on the beam. Why? Because summing the forces in the x direction gives us P. Since P is not 0, then the sum cannot be 0. This implies the structure is unstable. Here's another example. The structure is supported by a pin at A and a roller at B. The free body diagram for the structure shows three reaction forces all passing through point A. If a non-zero vertical force P is placed at the midpoint of member AB, then the sum of the moments about point A becomes P times L over 2. Since neither P nor L is 0, then the sum is not 0. This means the structure is unstable. Let's look at one more beam example. This beam has three reaction forces. Note how all of them pass through a single point, point D. If we subject the beam to a non-zero vertical force P at, say, point A, the moment equilibrium equation becomes P times L. Since this product is not zero, the equation is not satisfied. Therefore, the structure is not stable. Now, let's turn our attention to internal stability of structures. The discussion generally comes up when dealing with trusses. Assuming a truss is externally stable, we can determine its internal stability in one of two ways. The simplest way is to compare the number of equilibrium equations to the number of unknowns for the truss. If the number of equations exceeds the number of unknowns, the structure is considered unstable. Here is an example. This truss has 6 joints and 8 members. Since the number of equilibrium equations for a truss equals 2 times the number of its joints, we get 2 times 6, or 12 equilibrium equations. The number of unknown forces equals to the number of truss members plus the number of support reactions.
So for this kind of trusses, you have to find the number of equilibrium equations generated in this member or in this truss, and number of unknown forces of the structure. Okay, if the number of equilibrium equations is more comparison to your number of unknown forces, your structure will be called as unstable. Now, how to find the number of equations? You have to multiply, or you have to multiply number of joints with 2. Okay, so these are the joints 1 2 3. Let me note 1 2 3 4 5 and 6. These are the joints, so you have to multiply, you have to double the amount of number of joints, so that will be your number of equations generated on that truss. Okay, and the number of unknowns will be number of members. Let's see what it is.
Here, we have
Number of
8
members
plus
plus
3,
number of support
or
reactions.
11
Okay,
unknowns. Since
support reactions given by support reaction of these supports. So this pin will have one vertical, one horizontal, and this roller will have only one vertical. So number of support reactions will be 3. Number of members, so name these members: 1 2 3 4 5 6 7 8. So we have 8 members, so members will be 8 plus support reactions. So that is why you should know the support reactions given by these kind of supports. Okay, so number of supports are 3, so total is 11. So number of equations is 12, which is more than number of unknown forces, so this truss will be unstable. Okay,
the number of equations turns out to be greater than the number of unknowns, then we conclude that the truss is unstable. This counting technique, however, does not work in all cases. For example, consider this structure. The truss has 8 joints and 13 members. Therefore, the number of equations equals 2 times 8 or 16, and the number of unknowns equals 13 plus 3 or 16. Clearly here, the number of equations does not exceed the number of unknowns, yet the structure is unstable. Why? Because it can be shown that under certain loading pattern, the static equilibrium of the structure cannot be maintained.
See,
How?
if the number
Suppose
of
we place
equations
a
and
non-zero downward load.
number of equations and number of unknowns will be equal, then also your structure will be unstable. It has to be less. Okay.
Of P at the midpoint of the bottom chord of the truss. This makes the vertical reaction at the left and the right ends of the truss equal P over 2. Now suppose we conceptually cut the truss along a vertical plane as shown. Then we draw the free body diagram of each segment. We know that for the structure to be in equilibrium, the equilibrium equations must be satisfied for each segment. One of the equations, however, cannot be satisfied for either segment. Sum of the forces in the y direction is not 0. For the left segment, we have sum of the forces in the y direction equals P over 2. For the right segment, we have sum of the forces in the y direction equals P over 2 minus P, or negative P over 2. Since P is not 0, the segments are not in equilibrium. This means the structure is unstable. As you can see here, determining the internal stability of trusses may not be a simple task. It may involve careful inspection of the geometry of the structure. Generally speaking, if the geometry of a truss consists entirely of simple triangles like this, then the structure is considered stable. Otherwise, the structure needs to be carefully inspected for geometric patterns that are inherently unstable. Here is one such pattern. Any truss structure that embodies this rectangular pattern is considered unstable. See if you can figure out which of the following trusses are unstable.
Okay, that's what about the stability of your determinate and truss. How to find out that which beam or truss will be stable or not. Okay, which one will be stable, which one will be unstable. And then there are different ways to find out the support reactions for the stable and unstable members. Okay, so that's what about. So write all of you write your roll numbers in the chat box. Okay, I'll let go. Roll number 104 is there. Anyone like to write the roll number? I'll call out the roll numbers, okay? Just check once. 52, 86, 93, 82, 83, 99, 71, 70, 97, 92, 107, 90, 93, 90, 73, 120, 66, 63, 78, 51, 67, 77, 84, 76, 116, 68, 87, 85, 74, 109, 57, 94, 112, 88, 62, 118, 161, 53, 91. Anyone left? Anyone left?
101 is there.
Huh?
101 is 100.
I call out all names. Have you written? Have you wrote in this chat box? 101, 101. I didn't find any roll number with 101. Okay, okay. Yes, noted. 101. Okay.
Thank you, ma'am.
Join after 10 minutes. Okay. I won't be able to text in the group because today I don't have. I mean, Geo network is very poor. So please join after 10 minutes. Okay. I'll start the class after 10 minutes. Thank you.